Welcome to UNI-T Training. Let's look at vector signal analysis. First, let the signal generator output the digital modulation signal of a QAM16. Switch the working mode to Vector Signal Analyzer. Because the frequency of the carrier wave of the signal source is 60 MHz, we set the center frequency of the VSA to 60 MHz. Then inside the measurement settings, set the modulation type to QAM16. Click on Measurement Setup. Set symbol rate to 1 MHz. The maximum measurement interval can be up to 4096. Let's set it to 256. The longer the length is, the more data that will be parsed, and the test will be slower. Go back to Frequency menu. Set the span width to a multiple of the number rate being tested. The larger the multiplier is, the more accurate the measurement can be achieved, but the data will be slower because the signal source is set to a block rate of 1 megabits per second. Here we set the bandwidth to 4 megahertz. In the upper right window is the symbol signal. The blue trace is a code symbol. It is the time domain signal. The red line is the position of the corresponding point of each symbol. Because when the vector signal was generated, it has a baseband signal. The real data that was sent is the symbol. Go to Amp menu. Adjust the reference level and scale to the appropriate values. The lower left corner is the constellation chart. The constellation chart represents different phases and different amplitudes, which shows how the signal that is characterized. The gray dot is a starting point. The red dot is the measurement point. The more it shakes, the greater the error is. The lower right corner is the signal received after demodulation and analysis. There's EVM, which means the vector amplitude error. It can be used to characterize the signal modulation quality. Theoretically, the smaller the EVM is, the better. Here is the amplitude error, phase error, as well as the frequency error. Also, how much IQ data has shifted. The last one is the quadrant error. The I and Q channels of the signal are orthogonal. With this parameter, we can see what exactly the orthogonal error is. In addition to the above forms of analysis, if needed, we can select other formats to view. You can view the I-way or the Q-way signal. You can view the IQ track. You can also view the eye diagram of the I or Q path. The larger the eye of the eye diagram is, the better the signal quality is. Spectrogram traces can also be marked by marker dots or specific coded element points to analyze. Here you can see that we're using multiple marker dots. We're cycling between the different ones to give you pure examples of ways you can use these. Be sure to select which screen of the 4 screens shown here before selecting which marker dot you want to enable.